In the last lesson, you have learned about digital write function, pin mode function, and delay function. I have also discussed the concepts of inputs and outputs. In this lesson, I'll discuss the digital read function. Unlike digital write function, this function is directly associated with digital inputs. But here, the pin mode configuration will be different. Before going to discuss anything on digital read, let me tell you why it is used. A microcontroller is by default capable to read digital signals. That means high and low or 5 volt and 0 volt. That particular property helps it in numerous applications. For example, if an application needs to read the status of a button, like you have seen in many devices where a power button is there, you can press it once to start the machine and again press it to stop. That buttons are interplaced, the microcontroller gets a digital signal which is 5 volt or 0 volt. Another example is sometimes microcontrollers are used to count pulses coming from a sensor like encoder, which is used to calculate the RPM of a motor. There digital read is used. If you don't know what is RPM, then I am telling you it simply stands for rotations per minute. In some instances, microcontrollers are used to capture digital signals coming from other circuits like data pulses, commands, etc. It happens mainly in communication domain where microcontrollers are interfaced with Bluetooth, Wi-Fi, GSM, RFID modules. So a typical application can be the RFID card-based attendance system, which you may have seen in corporate offices. It is used. There is another example of digital read, that is in events. Events are important in microcontroller programming. When one input changes its state from high to low, that change can trigger something in microcontroller, such as make an output high or make an output low or send data, etc. For an example, do you remember when you have last visited an ATM counter to withdraw cash? Here I am trying to tell you an important concept. It happens mostly with me that the ATM machine screen shows bank ads as screensaver. But when I insert my card, the screen disappears and an user prompt comes where it asks for choosing a language. It means the process of inserting a card can trigger an event to the processor. Yes, it is related with digital inputs. Now you know why we use a digital read function. Let's see how we write the function. Or you can say, what is the syntax? Digital read is a return type function which returns a boolean value like true or false, high or low, 1 or 0. So when we call it, we need another variable where the return value should be stored. See this example. Int value equal to digital read within bracket parameter. The parameter here is the pin number which you want to read. If you connect a button at pin 11, then you should write 11 as the parameter. Whenever you call this function, the processor will read the pin status and store the result in the variable value. You may ask, why I have declared value as integer, whereas digital read returns a boolean value? You are right. See, I can also write value as bool, but the type of value will not directly affect the digital read function in any way. But more space in RAM will be consumed because a boolean variable takes 1 bit space, but an integer takes 2 bytes space. So as a programmer, you need to use that carefully. To clear all the concepts, I'll do an experiment with a push button. My objective is clear. My objective will be checking whether the button is pressed or not. If pressed, then trigger an output. And to do that, my methodology will be continuously checking the status of the button. If it is pressed, then switch on a LED. And if it is not pressed, then switch it off. Before telling you the circuit connections, I want to tell you how we can interface buttons with Arduino. There are two methods, pull up and pull down. See this circuit? In both the cases, I have taken output from resistor switch junction. The circuit on the right side is called pull down circuit. Here when switch 1 is pressed, we get a straight 5 volt, and when not pressed, we get 0 volt. The circuit on the left side is pull up circuit. Here when switch 2 is pressed, we get 0 volt, and when not pressed, we get 5 volt. So overall, we can say pull down has active high type output and pull up has active low type output. In my experiment, I'll be using pull down circuit. Let's see the circuit connection. Here one side of the switch is connected to 5 volt. The other side is connected to a resistor, just like pull down configuration. The junction of resistor switch is connected to pin 11 and LED is connected to pin 12 through a resistor. I may not use resistor for this small time experiment, but I always recommend you to use resistor whenever you are making such circuits. Now I guess you have understood the connections. Now let's make the circuit physically. Here what I have, Arduino Uno board, one breadboard with push button, one LED green and one 10k resistance and 3 jumper wires. So this is the switch. The two pins, if you look at like this, these two pins are short and these two pins are short. And when the button is pressed, these two pins, see, these two pins get short when the button is pressed. So this is how a push button works. And this is called, this button is called tic-tac. So I have placed the button in my breadboard. Now what I'll do is I'll make a pull down configuration. So here I am connecting the resistance with one side of the button, and these are 3 jumper wires. The red one should be connected to the 5 volts, so I am connecting it with one side of the switch. Blue one is the resistance switch junction and green is the ground, that is the other end of the resistance. So green one I have connected to ground and this is connected to pin 11. As in the circuit I have connected like that. LED, the positive one, is connected to pin number 12, other end is ground. Switch is in pin 11. That's how I made the circuit. Now I'll connect the USB cable to upload my program. Let me write the code now. Let me open the Arduino IDE. So in my code, first I'll give pin number 11 a name as button, as I have connected button at pin number 11. Now LED is at pin number 12, so I'm giving pin number 12 a name LED. Now in void setup I'll configure button as input. So pin mode button, comma input. and LED as output. So pin mode LED output. Now in void loop I am initializing a variable that is stat, and stat will store the return value of digital read. So I am checking the status of this button and I am storing the value in stat. So here I have to include an if-else logic. You can close this update notification. Now let me include one if-else logic. So if stat is equal to high, that means I have connected the circuit in pull down configuration. So when button is pressed, the stat value will be high. So if stat is equal to high, LED will be high. So LED will glow. And when button is not pressed, then stat's value will be low. So else if stat is equal to low, then LED will also be low. Digital write LED low. That's it. This is my simple program. So in my program I have initialized the button and LED, and in void setup I have configured button as input and LED as output. But inside loop what I did is I have initialized a variable stat which is storing the return of digital read. So by digital read I am checking the status of this button connected at pin number 11. So now I'll save my program as digital read. So let me save it. Now as I have connected the Arduino, so I'll check that the Arduino is connected properly or not. Now yes, Arduino is connected at COM5. Let me upload. Done uploading. Let's check the output. I have uploaded my program. Now let's see. See, I am pressing the button, LED glows. See, again. Here I am pressing the button, LED glows. Pressing the button, LED glows. So my program is working perfectly. In the next lesson, I'll discuss serial communication.